So we're going to start up a new unit on sequences. We'll see what that is today. So we'll talk about first what a sequence is. Then we'll talk about two main types, arithmetic and geometric, and how to tell if it's arithmetic or geometric. And then after that we're going to look for something called the nth term formula. And then that would be for both arithmetic and geometric. So that's our goals. Alright, so let's go ahead and write down what arithmetic or what sequences are in general here. So a sequence, well, what is it? It's a string of numbers that have a pattern. And we're going to look at two main types. There's the arithmetic one. That's a sequence whose successive terms have a common difference. There's the formal language. And what that really means is, what does difference mean in math? Subtraction. So if their successive terms have a common difference, like for example, what's the difference between 1 and 5?
4.
And what's the difference between 5 and 9?
4.
So there you can see that the common difference is 4. The difference that they have in common is 4. So there's your common difference. In other words, it's going up by addition. Now this is the English, so if you want to add this in parentheses to yourself on your notes there, arithmetic in English means going up by adding a number every time, or going down by subtracting a number. Because if you're adding a negative, that's like subtracting, right? And so we could be doing that also. Alright, so now let's move on to geometric. Geometric is a sequence whose successive terms have a common ratio. Ratio means what? Division, right? So if you were to divide 8 by 4, the second term by the first term, what would you get? 2. 16 by 8, so on and so forth. So what's happening is they have a common ratio. They're being, now in English we could say this. If it's going up because you're multiplying by the same number every time, here I'm multiplying by 2 every time, that's geometric. But you could also say if it's going down by what? Division. So it could be going down by division. If it's going down by division, then that's also geometric. So addition and subtraction is arithmetic. Multiplication and division is geometric. Okay? So that's the two types of sequences we're going to look at. There could be endless patterns, but we're going to look mainly at those two. Okay? Alright, so let's go ahead and get some vocabulary down here. So we're starting up kind of a new math topic here, so we need some new math symbols to represent this stuff. If this is my sequence, each one of these are a term, like this is the first term, the second term, the third term, so on and so forth. And how we label those with T, which is probably for term, and then the little subscript tells you what term it is. So T1 means it's the first term, T2 means the second. And then a lot of times we'll be talking about a general term that represents all terms, in which case we call that the nth term. How can you have a term that represents all terms? Well, it's a formula that you can use to plug in and get a term. So like, for example, this is the formula for the nth term down here. So if I wanted to find the 100th term, all I would do is plug in 100 for n, and it would tell me what the 100th term is. So those are some vocabulary words and some notation that we'll be working with. Alright. So, now we've already kind of addressed this, but I thought we better define this because I'm going to use these words. I need you guys to know what I'm talking about when we get there. The common difference in an arithmetic sequence. The common difference is the value that you're adding to each successive term. So in this case, now this is a tricky one. What am I adding to each number here? You're adding a -2, so the common difference is -2. So if it's going down, if I say you're subtracting, well really what you're doing is you're adding a negative, so the common difference would be a negative number is what you're looking at. Common ratio. In a geometric sequence, the common ratio is the value multiplied to each successive term. Now that's kind of hard to find. Like, what do you multiply 16 by to get 24? Well, I don't know, it's a decimal, right? But here's how you're going to find it. This is what I want you guys to write this down with me here, right? Oh, by the way, up here, why don't you guys put your loops here, the -2's, and put D equals -2. Now let's come on down here. How do we find this one? The common ratio, which we use the letter R, to find out what you have to multiply the first term by to get the second, so on and so forth, you divide the second term by your first term. So what is my second term?
24.
And what is the first term? So it's a fraction. 16 does not go evenly into 24. So what we're going to do is we're going to reduce it. I believe 8 goes into both of those. So 8 goes into 24 3 times, and it goes into 16 twice. So that would be your common ratio, 3 halves. You're multiplying each number by 3 halves to get the next one. All right. So what we're going to do now is we're going to put this stuff to work. So go ahead and write down your directions, A through C, and then number 1, please. Okay, well, here we go. So the first thing it's asking us to do for each one of these is to find the first 3 terms. So, in other words, they're asking us to find T1, T2, and T3, which means that, now what we have over here on the left is a nth term formula. This is a formula that will tell you any term you want if you just plug in the term you're looking for. So if I'm looking for T1, I'm just going to replace n with 1. So in this case, T1 would be 5 plus 4 times 1. Okay? Also, if we plug in 2, we'll have 5 plus 4 times 2. And the last one will be 5 plus 4 times 3. Now, what's important here, guys, is order of operations. A lot of us like to solve this math like we read a book from left to right, but that would be incorrect. Like some people might do, like down here on number 3, for example, you might do 4 plus 5 and get 9 and multiply that by 3. That would be wrong. You got to follow your order of operations. Multiplication comes first, right? So let's go ahead and do that. 4 times 1 is 4. That's what we do first, and then you add the 5, which is 9. The next one, 4 times 2 is 8 plus 5 is 13. And then 12 plus 5 is 17. All right, so that's part A. Part A is done. I found the first 3 terms, 9, 13, and 17. Now, part B. It says determine whether it's geometric, arithmetic, or neither. Alright, well, to do that, let's start with arithmetic. That's usually easiest. So what are we doing to get from 9 to 13? Adding 4. And how? Now, here's the thing, though. You could do that with any 2 terms. So that doesn't tell us if it's arithmetic or geometric. In order for it to be arithmetic or geometric, it has to do the same thing to get from the second term to the third term. So let's see that. If I add 4 to 13, do I get 17? So there you go. That's enough information right there. We're adding 4 both times. When we're adding, is that arithmetic or geometric? That's arithmetic. So the answer to part B is arithmetic, because we're adding 4 every time. All right, part C. Part C says find the common difference if it's arithmetic, or common ratio if it's geometric. Well, it's arithmetic, so we're looking for the common difference. What is the common difference?
4.
It's 4. It's 4. All right. Let's go ahead and write down number 2 if you haven't already done so. Okay, number 2. All right, part B, or number 2, part A. All right, so we have a different sequence this time, or a different nth term formula, but we're still looking for the first 3 terms. So we're going to be plugging in 1 for n in the second formula here, which is going to give us 1 squared. And then we'll plug in 2, and then 3. So 1 squared is 1, 2 squared is 4, 3 squared is 9. So that's part A. We plugged in 1, 2, and 3 and got our first 3 terms, 1, 4, and 9. Obviously, it can go on forever because we can plug numbers in forever, right? But part B, we're going to move on to a new question and determine whether this is arithmetic, geometric, or neither. Let's see. Well, let's try arithmetic. What do you have to do to get from term 1 to term 2? You have to add 3. Now, is that the same thing you do to get from term 2 to term 3? No. You'd have to add 5. So that's no good. So we know it's not arithmetic. Let's try geometric. Now, that one's a little bit trickier. You have to find the common ratio. You guys remember how to find the common ratio? Yeah. You divide the second term by the first, or the third term by the second, and so on and so forth. So let's go ahead and do this one. What is 4 divided by 1? Okay. And what is 9 divided by the one before it, which is 4? So are these the same? It's not geometric either. This one is neither. Therefore, we don't need to do part C because it's not geometric or arithmetic, so there's no common difference or common ratio to identify. All right. So we're going to find the first 3 terms, T1, T2, and T3. So we have 3 times 2 to the 1, 3 times 2 to the second, and 3 times 2 to the third. What do I do first, guys? You do the power first, right? Exponents first in order of operations. So what you're going to do first is 2 to the first power. What is 2 to the first power? 2. And then you do your multiplication. What's 2 times 3? 6. Now we're going to do this power first. 2 to the second is? 4 times 3 is? And the last one, 2 to the third is? 8 times 3 is? 24. All right, so that's part A. You got to do that order of operations. Remember, math is not English. We don't necessarily go left to right with our operations. All right, part B. Determine if it's arithmetic, geometric, or neither. So, if I were to subtract the first 2 terms, I would get a common difference of what? 6. Would that work for the next pair? No, because if you add 6 to 12, you do not get 24, right? So it's not 6. Now let's try ratios. If you divide the second term by the first term, we get 2. And if I divide the third term by the second term, I get, do they have a common ratio? Yes. They do, therefore this is geometric. And since it's geometric, we can identify our common ratio, which is what? 2.